Okay, today we're going to be talking about a special kind of relation called a function. From what we did last week, we said that basically a relation was any type of pairing of an x value with a y value. And today we're going to be looking at a special case where certain relations follow a specific pattern. Okay? So for the definition of a function, this is going to be a special relation where each input, and when we talk about input, we're talking about our x values. This is similar to what we did with the computer programming in the code.org. You had the input, you would plug something into the program, and it would produce something, an output. Okay, so everything that we're going to be dealing with as far as input and outputs with our functions here are going to always be numbers for the data type. So this is a special relation where each input, or your x values, has exactly one output value. And those output values, again, are called our y values. So for each input, for each single x value that we plug in, we can only have exactly one y value that gets associated with it. Another way to think about this would be to say that our x's cannot repeat. So our x values cannot repeat. So if we're talking about relations in the form of a list of ordered pairs, because this was one way that we could write a relation, something that would be an example of a function would be something like this. If I had the ordered pair 0, 6, 5, negative 2, 7, and 9, and then 11 and negative 1. Okay. Now remember, what we care about is that for each x value, there's only one y value that goes with it. So I'm focusing in on all of these x values here. So when x is 0, where I've highlighted the 0 in yellow, it's being assigned to only one y value, and that's 6. When x is 5, it only gets assigned to one y value, and that's negative 2. When x is 7, it only gets assigned to one y value, and that's 9. And when x is 11, it only gets assigned to one y value, and that's negative 1. Okay, so far this relation would be a function because for each x, we only are hooking up with one y value. Okay? An example of something that would not be a function. So if I go back to my list of values again, let's say that I have the ordered pair negative 4 and positive 1. I have another ordered pair negative 1 and positive 7. And then I have another one, negative 1 and positive 2. And then one more, positive 5 and positive 6. Okay. Let me go back and highlight our x values here. We have negative 4, negative 1, negative 1, and 5. Okay. So here we have a problem with the second and the third ordered pair. Okay. If I look at the second ordered pair, the x value of negative 1 is hooking up with the positive 7, but then in the very next ordered pair, negative 1 is also hooking up with the positive 2. Okay? Each x value can only date one y value at a time. So this would be an example of something that's not a function. These negative 1 right here are going or hooking up with two different y values at the same time. So that would not be considered a function. So looking at these next four examples, we're given the relation as a list of ordered pairs. I want to go through to determine if it's a function or not and focus in on my x values. Okay, Okay, so let me highlight the x values here. We have the x values of 5, 3, 2, 0, and -1. None of the x values repeat, so for each x value, it's being assigned to only one y value. Okay. Now, don't let y values that repeat confuse you. Okay, so for example, in this first order pair here, we have +5, and that's dating or going out with -2 for the y value. We also have that +2 is going out with or hooking up with -5, or sorry, I'm at the next order pair here. The 0 is going out with the -2 as well. Okay, so all we care about is the x values. Each x value can only be assigned to one y value at a time. You can have multiple y values going out with the same number or being assigned to different numbers, but you can't do the other way. You can't have x's that are being assigned to multiple y values. So again, I would just focus in on the x values, check and make sure that none of them repeat. So this one would be that yes, it is a function. Okay, let's look at number 2. Again, we're just focusing in on my x values. So we have an x value of -2, x value of 0, x value of 2, x value of 3, x value of 2. Okay, and we're looking for any that repeat. And right here, x value of -2 is being assigned to -4, and the last ordered pair, x value of 2, is being assigned to +4. So this would be no, it is not a function since you have the same x value being assigned to more than one y value. Let's go back to example 3 here, focusing in on our x values. So -4, -3, -2, +1, and -3. Okay. And again, looking at this, I do have a problem. -3 appears here in this ordered pair, but -3 also appears as an x value in the last ordered pair. So this one cannot be a function. So we would say no. For number 4, go back through and focus on our x values again. We have +1 as our x value here, +2, 3, +4, and +5. None of the x values here repeat, so this one is good. So the answer would be that yes, this relation does represent a function. Okay. Now remember last week we also talked about that we could represent relations using XY tables instead of just listing out the ordered pairs. Same concept applies here. We're going to look at our list of x values. Okay, so we're only focusing in on the x values, and we're checking to make sure that none of these numbers repeat. So unfortunately, we do have a problem. The first one, x value of 3, is being assigned to 5, but then in the last one, x value of 3 is also being assigned to 3. Okay, so since the 3's repeat in the x column, this cannot be a function. Moving on to the next one, if I look at the table and look under the x column here, I have -4, -2, +1, +2, +5. None of these x values are repeating, so we are good. This relation could be called a function. So we would say yes. Example 7 here, again, focusing in on just my x values. I have -5, -3, 0, +1, and +2. None of those repeat. So since none of them repeat, I could say that yes, this would be a function. Okay. Example 8, looking at my x values again, we have +1, +4, -7, +4, and -1. Okay. Do any of the x values repeat? And the answer is yes. 4 is hooking up with -3, but 4 is also hooking up with +2. Okay, this is a no-no, so we would say that the answer would be no, this is not a function. Okay, example 9, looking at my x values again, we have -8, -4, 0, +4, and +8. We're checking to make sure that none of the x values repeat there, and none of them do, so this one would represent a function. So we would answer yes. Okay. Example 10, looking at my x column here, I have positive 1, positive 2, positive 3, positive 4, and positive 5. Again, none of the x values repeat, so this one is good, so we would say yes, this relation is a function. Okay. And we also talked about another way to represent a relation is by looking at the mapping, where you have the different values with the bubbles and the arrows showing you which x value gets assigned to which y value. So now in a mapping, you're not going to see the x values repeating. They're not going to repeat the actual number. What you're checking to make sure is that you do not have two arrows coming off of the same x number. Okay? So if I look at the -3 here, it only has the one arrow coming off of it from -3 to 0. That tells me that I have the ordered pair -3, 0. That's the visual way of representing it when we do a mapping. -1 is being assigned to the 4, 2 to 7, and 4 to 4. So this one would be yes, it is a function because each x value only has one arrow coming off of it. Right, looking at number 12, again, -4 only has one arrow coming off of it, going to +4. Now, we do have a problem with this next x value of -1. If you notice, it has two arrows. So -1 is being assigned to -1, but -1 is also being assigned to +7. So right away I know that this cannot be a function. For the last mapping here, -1 is my x value. It has an arrow going to 2, so only one arrow, we're good. 0, we have one arrow going to 1, only one arrow, we're good. +1, one arrow going to 2, we're good. +2, only one arrow going to +5, we're good. So this mapping does represent a function, so the answer there would be yes. Okay. And we have one more way to check to see if a relation is a function, and that deals with if you're given the graph of a relation. The graph was the other way that you could represent a relation. Okay, so we could list out the ordered pairs, we could make an XY table, we could do a mapping, or the last thing we could do was to plot the points and graph it. So when we're given the graph of a relation, oftentimes we'll use something called the vertical line test to determine whether the relation is a function. Right? And what the vertical line test states is that if a vertical line if a vertical line intersects, okay, sorry about that. The recording got interrupted by a phone call. Picking up where I had to stop off in the previous clip. If a vertical line intersects a graph more than once, then it is not a function. Okay. So remember, vertical lines are going to be lines that go straight up and down. And the idea being that if I were to draw a vertical line, or even hold your pencil on top of the graph straight up and down like a vertical line, and drag your pencil from left to right across the graph, that vertical line should never cross the graph or intersect more than one point as you drag it from left to right. Okay. So an example here of something that would be a function, and this is something that you guys dealt with last year in pre-algebra that you graphed quite a bit. You graphed a lot of lines. So if I drew the graph of a linear equation like that, I'm just going to pick a generic place to put a vertical line. So So let's say this dashed line here is my vertical line. Notice that it's only going to cross the blue line, the blue graph of my relation, in one spot. As I move that red dashed vertical line to the left or to the right, that point where it intersects is going to also move left or right. So it's only going to intersect or go across that blue line in one point as I go from left to right. So this would be an example of something that is a function. It passes the vertical line test. Okay? Now let's take a look at something that would not be a function. So let's set up our x and y axis. Okay, and let me graph a circle. Now we won't actually get into graphing or dealing with the equations of circles. You'll talk about that when you get into geometry and algebra 2. But this is a good example of something that would not be considered a function. If, let's say I pick right here to draw my vertical line going up and down. Well, at the very top of the circle, I intersect here, but then at the very bottom of the circle, I also intersect there. Okay, so I have two intersection points. Sorry, my pen's not working very well in the program. Two intersection points. Okay, so this would not be a function, so the answer would be no, that it is not a function. Okay, and again, we're just looking at, can I draw a vertical line that crosses the graph in more than one point, or that intersects more than one point? Okay, so looking at example 14 here, we talked about these types of graphs last week, and just as a reminder, this is what we call a discrete graph. Okay? And it's called discrete because these are points that are not connected. There's gaps in the points, so this is a discrete graph. So my goal is I want to make sure that I cannot draw a vertical line that crosses or intersects more than one point. And right away on the far left here, I can see that if I draw a vertical line right here, I'm going to intersect this point, which is the ordered pair -3, +1, and I'm also going to intersect this point, which is the -3 and what? 1, 2, 3, 4, -4. Okay, so the point -3, +1, and the point -3, -4. Again, we can see here we have the same x value repeating that's going or being assigned to two different y values. So this is not a function. So I would say no for this one. Okay. Let's see, for number 15, if I draw a vertical line here through this point, it only crosses at that one point. If I draw a vertical line here, it only crosses once. Here, it only crosses once. Here it only crosses once, and here it only crosses once. So this would be an example of a function. So we would say yes, it is a function. Okay. For number 16, okay, again, if I draw a vertical line, let's say I draw it on the very far left side of the graph, and as I drag this to the right, I'm only going to ever cross the line in one spot. So this would be an example of a function. We would say yes. Okay. Number 17, I could draw a vertical line right here. It's going to cross here at the top of this U-shaped curve, and it's going to cross here at the bottom again. Okay. So we have two spots or 2 points of intersection, so we would say that the answer is no, it is not a function. Example 18, we have another example of a circle here. Okay, I'm just going to pick a generic place to draw that vertical line. We cross here at the top of the circle, and we cross here again at the bottom of the circle. Okay, so we have 2 points where we cross. That means that it cannot be a function. So the answer would be no. Number 19, if I start on the left side of the graph, I'm only going to cross in 1 point as I drag this vertical line. So imagine this is your pencil laying on top of the graph. As I drag the pencil across, it will never cross the graph in more than 1 point as I go from left to right. Okay, so this one would be a function. And I guess just to mention, since we talked about the vocabulary word discrete, remember these graphs like number 16, 17, 18, and 19? These would be called continuous graphs because they are connected. Remember, continuous means I could start putting my pencil down to draw the graph, and I can draw it without ever having to pick my pencil up off of the page. Okay, so those would be all examples of continuous functions or continuous graphs. Okay, number 20. Okay. We are given an actual vertical line, so if I were to draw another vertical line on top of it, I actually intersect the black line here in multiple places. Okay, I could say that I intersect here, here. So all the way up and down here, I'm going to have infinitely many intersections. So this would be an example of something that is not a function. Okay, so it is not a function. Let's see, 21. This goes back to some of those wavelengths and wave examples that you were talking about in science. This is one of our trig functions. If I look at this, when I draw my vertical line here, let's say I only cross in one spot. As I go from left to right, I only cross in one spot as I go. This point, as I drag the vertical line this way, this intersection point is just going to move along the curve. Okay, but it will only have one intersection point as I move across the page. So this would be, yes, it is an example of a function. Okay. So again, the goal for this lesson is that can you tell me from a list of ordered pairs, is the relation a function? Can you tell me from an XY table if the given relation is a function? Can you tell me from a mapping if the relation is a function? And can you tell me from a graph if the relation is a function?